Solving absolute value inequalities. So again, still continuing with chapter 9, inequalities. We've done graphing inequalities on the number line. We did solving inequalities, one variable inequalities. And we did absolute value equations. And now we're going to do absolute value inequalities. Okay, so absolute value inequalities. Okay, so what we're going to do, this is going to be the order of how we're going to solve these. So the first step we're going to do is we're going to write the absolute value inequality as an equation. Okay, so we're going to write absolute value inequality as an equation. Okay, so we're going to be changing it to an equal. The second step is just like we did yesterday with our absolute value equations, we're going to write two equations. Then you're going to write and solve your two equations. And what we're going to do is we're going to be finding our two boundary points from this. So we're going to write and solve your two equations to find your two boundary points. So like our absolute value equations, we usually got two answers. Our absolute value inequalities, we're usually going to have two boundary points. Now, the next step, what we're going to do is we're going to check a value into the original inequality to see where to shade. And I know when we did inequalities the other day, I showed us one way where we did set it as an equal and we checked, and then another way that we didn't. For the absolute value inequalities, for us right now, I think the easier way is to actually set it to an equal and to check. Check to see if you're going to shade in between your two boundary points or outside of. That's usually going to be our two cases. So either shading in between the boundary points or outside of the boundary points. So again, either shading in between the boundary points or outside of the boundary points. Okay. And the last thing we're going to do is after we decide if we're going to shade inside or outside, then you're going to obviously graph your solution on a number line. and give your answer as an inequality. Okay, so let's jump into an example. So our first example, let's say we have the absolute value of 3x minus 6 is greater than 30, okay? So what we're going to do first is we're going to think of this as an equal. Okay, we're going to rewrite it as an equal. We're going to write it as the absolute value of 3x minus 6 is equal to 30. And we're going to write our two equations. Now, the other day, I had you guys check to see if this was positive or negative. In this case, since we're talking about greater than or equal than, I can have it actually be a negative here because it's possible for something to be greater than a negative. So I am going to write my two equations. So my first equation is going to be 3x minus 6 equals 30. And my second equation is going to be 3x minus 6 again, just taking what's inside the absolute value. And this time I'm going to set equal to a negative 30. And then I'm going to work these two out. So first thing I'm going to do, I'm going to add 6 to both sides here. And when I add 6 to both sides, I get 3x is equal to 36. Then I'm going to divide both sides by 3, and I get x is equal to 12. So 12 is going to be one of my boundary points. Over here, I'm going to do the same thing. I'm going to add 6 to both sides. And when I add 6 to both sides, I'm going to end up with 36 is equal to a negative 24. And when I divide by my 3, I get x is equal to negative 8. And those are going to be my two boundary points. So now I'm going to draw my number line. And I'm going to put my two boundary points, making sure that I go from smallest number to largest number. So the negative 8 is going to go here. I don't put it in the order I necessarily get. Negative 8 is the smaller, 12 is going to be the bigger. And I need to decide if it's going to be open or closed circle. So when I'm looking at this, you'll notice that this is going to be an open because there's no equal underneath. So I'm going to have an open circle here, and I'm going to have an open circle here. Again, because of this inequality, it does not have the little equal. Now I need to decide, am I going to shade in between my negative 8 and 12, or am I going to shade outside of it? So I'm going to test a point. And usually what I try to do is I try to test a point that's in between. If it makes it true in between, then that's where I'm shading. If it does not make it true in between, then I'm shading outside. So I'm either going to shade inside or I'm going to shade outside. So let's say I'm going to try 0, and 0 is going to be in between here. So I'm going to try 0. And so I'm going to put it into the original inequality right up here, into the original inequality. So I'm going to go absolute value of 3 times 0 minus 6 less than 30. And I want to see if this is true or false. Well, 3 times 0 is 0, and 0 minus 6 is a negative 6. So I'm going to get the absolute value of negative 6 is less than 30. And anytime I take the absolute value of anything, I always get a positive. So the absolute value of negative 6 is 6. And now, is 6 less than 30? That's what we need to decide. And 6 is less than 30. This is true. So that means I'm going to shade where 0 is. Shade where 0 is. And that's in between these two numbers, okay? So again, my 0 would be somewhere in between these two numbers. It's in between negative 8 and 12. It made it true, and I always shade where it's true. So that's going to be my graph, okay? Now I also need to give an inequality. So if you remember from the first day when we were learning how to graph these, what you want to do is you're going to start with the smallest number, and I'm going to go -8. And since it's an open circle, less than x, less than 12. These inequalities always have to point the same direction. And if you start with the smaller of the two numbers, there will always be less thans or less than or equal to if it's a solid circle. So this is our graph. And this is our inequality answer. Okay, so let's try another one. Okay, so our next example, let's try absolute value of 2x minus 1 is greater than 23. Again, we're going to rewrite this as an equal. So let me change this to absolute value of 2x minus 1 is equal to 23. And I'm going to write my two equations. So I'm going to take what's inside the absolute value, which is 2x minus 1. I'm going to set it equal to 23. And then I'm going to take what's inside my absolute value, 2x minus 1, and I'm going to set it equal to the opposite of this, which is a negative 23. And I'm going to solve both of these to find my two boundary points. So I'm going to add 1 to both sides. And when I add 1 to both sides, I get 2x is equal to 24. I'm going to divide both sides by 2, so I get x is equal to 12. So that's one of my boundary points. Over here, I'm going to add 1 to both sides, and I'm going to get 2x is equal to a negative 22. I'm going to divide both sides by 2, and I get x is equal to negative 11. These are my two boundary points. So I'm going to draw my number line. Again, start with the smaller of these two, which is my negative 11. And then I have my 12. And I need to look to my original problem to decide if it's an open or closed circle. So I'm looking at this inequality. There's no little line underneath. So it is going to be an open circle. So open at negative 11, open at 12. And then I need to decide, do I shade in between or do I shade outside? So again, let's figure out which direction I shade. So again, an easy number to try is 0. You never want to try any of your numbers that are a boundary point because those make it equal. And we want to make sure we're deciding what's not making it equal, but making this inequality true. So I'm going to test 0. Okay, so I'm going to try 0. Okay, and 0 is going to be in between these, just so we understand. It'll be closer to negative 11, but not that much closer. So that's where my 0 is about. So I'm going to put it into my original inequality. Okay, so again, this is where I'm putting it into. And so when I put it in, I get the absolute value of 2 times 0 minus 1 greater than 23. And when I take the absolute value, 2 times 0, I get 0 minus 1. I get the absolute value of negative 1 greater than 23. And the absolute value of negative 1 is really just a 1. So I get 1 greater than 23. And I have to decide, is that true or false? Well, 1 is not greater than 23. So this is false. So what that means is here where 0 is, makes it false. This is not true. You never shade where it's false. So that means if this is false here, it has to be true outside. So we're going to be shading this direction and this direction. And that's going to be our graph. So now I need to do the inequality. So when you have two separate pieces of graph, you take the, define this inequality, you define this inequality, and then you write the word or in between. So this is going to be x is less than negative 11. Doesn't matter which one you start with first. I usually start with the one on the left. And then you need the word or, and the other one's going to be x is greater than 12. So again, I define this one, x is less than negative 11, or x is greater than 12. And that's going to be my graph. and my solution as an inequality. So let's try another one. And actually, before I do another example, I'm going to go through a couple of special cases that you might see that might save you some time if you see this happen. So, special cases. So, when we're solving absolute value equations, we do not want a negative on the other side of the equal. Otherwise, it's no solution. Now, it may not be no solution when we're doing our inequalities, but it is going to be a special case. So if you have the absolute value, I'm just going to write the word inside. So if you have an absolute value, got something inside this absolute value, and it is greater than, let me put greater, it is greater than a negative number. That's going to be a special case. So whenever you take the absolute value of something, remember you always get a positive number. So if I'm getting a positive, every time I'm taking the absolute value, it will always, always be bigger than a negative. So this is going to mean it's going to be all real numbers. Everything's going to be a solution. It doesn't matter what you put in here, it's always going to be true. Now, also with this, if the absolute value is greater than or equal to a negative, that would be a similar situation. So again, your absolute value is always going to be a positive, okay? So what this is really saying here is this is going to be a positive greater than or equal to, depending on the case, a negative. And we need to decide if that's true or false. Well, that's always true. Always true. So what that means is that whenever I have these two cases and I have an absolute value and it's greater than or equal to a negative, my answer is going to be all real numbers. Or you can also write it this way. This is a symbol for it. When you have double lines here on your R, that symbol means all real numbers. Okay, so now let's say that we have the following. Let's say that we have it be the opposite, where it's going to be less than or equal to a negative. So if the absolute value is less than a negative number, or if your absolute value is less than or equal to a negative number, what that means is the following. Basically, I'm going to have the following situation. It's going to be, let me do this in a different color. It's going to be saying that we have a positive, because this is always going to be a positive here, is less than or equal to, depending on the situation, a negative. Now, is a positive going to be smaller than a negative? Never true. So if you have a negative on this side and your absolute value is less than a negative, or your absolute value is less than or equal to a negative, your answer is always, always, always going to be no solution. Nothing's going to make that true. So let's look at an example of this. Okay, so this just kind of saves you some steps if you look and recognize this. Otherwise, you'll see this when you check your number in between, but this just saves you a step. So let's say, for example, we have the absolute value of 2x plus 4 is greater than or equal to negative 12. Okay, so again, you want to pay attention to this. We have a negative number here. Okay, so that's what we're paying attention to, negative. And again, let me just say what this is saying here. This is saying, because this, no matter what I do, when I take the absolute value, I'm always going to get a positive. Is a positive greater than or equal to a negative? And again, that is always true. So when I see this problem, I know my answer. My answer is going to be the following. It's going to be all real numbers. Okay, that's how you're going to write it. You don't have to write it as an inequality because everything's a solution. And then in terms of the graph, you're going to graph everything. So if this is my number line, I'm going to shade everything. Okay, everything is being shaded. So this is going to be, let's grab another pen here. This is going to be my answer and my graph. So let's try another one. Okay, so let's say, for example, I have the absolute value of 3x minus 7 is less than or equal to a negative 10. And again, you notice that, again, this is a negative. And just like the other day when we were trying to decide if it's positive or negative when we're doing absolute value equations, we always want to make sure that our absolute value is isolated first. All of these ones are, okay? But you always want to make sure that they're isolated. And now, again, let me just kind of state what this is saying here. So this is an absolute value, and this absolute value is always going to be positive. And what they want to know, is that going to be less than or equal to a negative? And again, will a positive ever be less than or equal to a negative? Never. So that means my answer is going to be no solution. And if they gave us a graph, a number line, you're actually going to leave it blank. So I'm just going to say blank or no graph. You're not going to put anything on the graph because when you put something on the graph, you're graphing what makes it true. Nothing makes it true. And there's your answer and your graph again, which is blank. Okay, now what if we end up with this being a 0? 0 is also another situation that's kind of a special case. So if you have it greater than 0, less than 0, those are special cases. So I'm going to talk about that next. So I'm going to say more special cases. And this time I'm going to be talking about having 0 on the other side as opposed to a negative. So this one I'm going to have broken down into a little bit different situations. I'm going to have 4 situations. So I'm going to have absolute value. Again, I'm just writing the word inside it, just so you guys know, absolute value, whatever's in the absolute value, if you have it being greater than or equal to 0. Again, what this is saying is a positive number greater than or equal to 0? Okay, that's really what it's saying. So let me just jot that down in a different color. So this is saying positive greater than or equal to 0. And that's going to be true. Okay, that is going to be true. So my answer for this is always going to be all real numbers. And again, on my number line, I would shade everything on my number line. And this would be my answer, and this would be my graph. Now, if I have the absolute value is greater than 0, okay, that situation is going to be true for every single thing except for what makes it 0. So there's going to be something that's going to make this absolute value 0. We cannot have it be 0 because it has to be greater than or equal to 0. So in this case, this is going to be a slightly different answer. It's going to be all real numbers except the value that makes it 0. So what would happen is on the graph, I would have every single thing shaded, both directions, except for the one number that makes this 0, and have an open circle there. Okay, so let me just label this special case 1, special case 2, and special case 3. So now I'm going to talk about this being less than or equal to 0. So let's say that the absolute value is less than or equal to 0. So if it's less than or equal to 0, this is going to be negative, always a positive. It could be 0, but it's never going to be a negative. So is a positive going to be greater than or equal to 0? No, except where it's going to equal 0. So in this case, only what makes it 0. So only what makes it 0. So in that case, you would have a closed dot just at what makes it 0, and you would have no shading. It would just be a single dot. And the last one of these special cases, if you have the absolute value is strictly less than 0, so I can't have it be 0. Again, an absolute value is always positive or 0. It will never be negative. So will something that's not negative be less than 0? No. So this one would be no solution. No solution. And again, you would have a blank graph. Okay, so let me just show you what that would look like. So that's going to be our next set of examples. Okay, so examples where I have 0 on the other side. If I have absolute value of 2x minus 1 is greater than or equal to 0, and I'm just going to keep the absolute value of 2x minus 1, and I'm just going to change what this says. So if this is greater than or equal to 0, no matter what number I have here, it's either going to be a positive number or it's going to be a 0 possibly. So what this is going to be is this is going to be all real numbers. And I'm going to have my graph, and I would graph everything. And that's my answer, and that's my graph. Now, if I slightly adjust this, where now it's still 2x minus 1 inside my absolute value, but now it's strictly greater than 0, what it means is whatever makes this 0 cannot be part of my solution. So I want to check and see what would make that 0. So when I do this math and I add 1 to both sides, I'm going to get 2x is equal to 1. I'm going to divide both sides by 2 and I get x is equal to 1/2. So 1/2 makes my absolute value equal 0. and I cannot have it equal 0. So every other number is going to work because every other number is going to make it a positive. This is the only number that's going to make it be 0. So my answer is going to be all real numbers except 1/2. That's really going to be what's happening here. Now, I'm going to write it as an inequality here in a second, but I'm going to have 1/2 on my number line. It's going to be not included. It's going to be an open circle, and I'm going to shade everything this direction and everything this direction. It's literally everything except for 1/2. Now, looking at this is actually two separate inequalities. One inequality is x less than 1/2. The other inequality is x greater than 1/2. So my answer is going to be x is less than 1/2 or x is greater than 1/2. And that would be my answer. So again, my graph would be everything but 1/2. And my inequality would be written as an or because I have this piece right here, which is x is less than 1/2, and this piece here, which is x is greater than 1/2. Okay, now let's say I'm changing it to less thans and less than and equal to. I'm going to take 2x minus 1 is less than or equal to 0. So in this case, this is always going to be positive or possibly 0. It's never going to become a negative answer. So since this never can be a negative, it will never be less than 0, but it could equal 0. So it's going to be basically anything that makes it 0. So again, 2x minus 1 equals 0. I just solved that up here. What makes that 0? 1/2. So this is the only true part. Everything else is going to be false. So my graph is actually going to look like this. I'm going to have my 1/2 on it, and 1/2 is going to have a closed dot, and that's going to be my graph, and my answer is going to be x equal 1/2. That's it. That's the only thing that's going to make it true. Everything else would make it be a positive, and a positive will never be less than a negative. But the 1/2 will make it be equal to 0. And the last one is absolute value of 2x minus 1 is less than 0. So in this case, this one's kind of our easy one because this will never be less than 0 because this is either going to be positive or 0. So this answer is going to be no solution. And again, if they had a graph drawn for you, you're going to keep it blank. You're not going to have anything on the graph because you're only graphing what makes it true. And that's going to be your solution. And that's our notes on absolute value inequalities.